Hello everyone. In this video I'm going to talk through one of the probably most misunderstood areas of physics that I often teach about. It's a phenomenon known as the Doppler Effect and was first described by an Austrian scientist, Christian Doppler. When looking at the change in frequencies or apparent change in frequencies as a result of motion between a source and an observer. Now the title looks a bit unusual, but really the Doppler effect is all about, if you look at the letters here, you can see they seem a bit more compressed, whereas here the letters on the title I've deliberately put a bit further away. This whole idea of compression and spreading out really underpins this effect. And we're going to use a police car in the middle to describe what's going on. If we imagine this police car is our source, so this is our source and it's going to produce characteristic sound waves. We all know the sound of a police car. I want you to imagine now that standing over here, let's just say on a field, is you. Little smiley face there. Now, as that source moves closer to the person, it's going to sound, or the sound that is perceived rather, will seem to have a higher pitch. And that's because the sound waves, if we just draw in black for a moment, sound waves, if we draw them a bit like this, notice that they're similar distance. The sound waves will move towards the person, and you normally, if the car was stationary, let's say, would hear the siren. But if the car were moving in this direction, if the car were moving towards the person, now I'll draw this in blue, what you get is more of a compression of those sound waves as it's moving. And the sound waves behind the car almost appear to be spreading out and they move further apart from one another. So as the source moves closer to the observer, and we're saying the observer is yourself at this point here, then the sound waves almost get compressed in this region here. So you get compression. Of the sound waves there, and over here you get spreading out. Now when those sound waves get compressed, what we're saying is that there's a reduction in the distance between those waves. So we actually get a reduced wavelength. So here, in this region here where we're getting those waves being compressed, the wavelength actually decreases. And the symbol for wave, we're going to use the actual symbol of lambda, the Greek symbol to represent wavelength. The wavelength actually decreases. Now, because that decreases, what you get is an apparent increase in the frequency. Frequency measured in hertz is the number of waves that pass a point per second. So if we've got more waves tighter together, then clearly we're going to get more waves passing a particular point in a given second. So the increase, or the decrease in wavelength rather, gives us an apparent increase in frequency. Now when we get an increase in the frequency, then what that ultimately leads to is an increase in the pitch. So that's why when the source moves closer to the observer, we get compression of the sound waves being produced. The wavelength decreases, the frequency increases, and so the sound sounds higher pitched. If when the car passes the observer though, it then continues to drive on, it passes beyond the observer, then it's moving further apart. And you always get a reversal. You get this spreading out part seen. So if the car were moving in the other way, let's just draw it at the top here. If the car were moving in this direction, then what you'd get is compression of these waves here as the car moves that way. And you'd get a spreading out of these waves as the car is moving away from the observer. So the Doppler effect is all about this apparent or shift in frequency you get because of these compression of the sound waves. Now, actually, if you were to look at, just a really simple example, if you were to look at a little, not the best drawing, but a duck. Simple duck in a pond. I'll just colour the duck in really small, because this is probably an easier example to look at. When you look at a duck moving, as it's moving to you, for example, what you'll notice is that the waves here seem to be quite compressed. So as the duck is moving in this direction, you notice that the waves in the direction that it's moving seem to get compressed, and they seem a lot more spread out behind the duck. And that again is to do with the Doppler effect. Because the waves are getting compressed, the frequency of them is increasing. Okay, hope all that helps.